All right. Now, first thing is let's identify the difference between what is a parametric data and what is a non-parametric data. Let's look at the difference. Okay. Let's look at what is parametric and what is non-parametric. Okay. Now your parametric data. Okay. What is parametric? What kind of data can be called as parametric? What would be the level of data for parametric? Level of data. It's always going to be interval and ratio. Okay. Always remember it's going to be interval and ratio. Okay. So either your interval or your ratio data are going to be under parametric. Now, what is this interval and ratio? What do I check? Where do I check is interval or ratio falling in place of your dependent variable? What is your dependent variable? You all know what is independent variable, what is dependent variable, right? So whatever is your dependent variable, let's say you're checking VAS. Okay, that's your dependent variable, checking the pain on the VAS, the outcome. So is the outcome an interval or a ratio? If it's an interval and ratio, most likely it's going to be under parametric. What if the outcome is nominal and ordinal? Then it's going to be non-parametric. Okay, so your level of data for using non-parametric tests means the dependent variable would be nominal and ordinal, and parametric, the dependent variable would be interval and ratio. Okay, now which one is a stronger test? Is it parametric or is it non-parametric? Definitely parametric because it has interval and ratio, right? So it's going to be your parametric tests that are stronger, non-parametric are weaker. Which test can you actually generalize to the entire population? Which test should you generally generalize to the entire population, parametric or non-parametric? It's going to be a parametric test. They are stronger tests and they can be generalized to your entire population. Okay. What about non-parametric tests? They're weaker and we're not really generalizing them to the entire population. What about the groups? Which one has equal groups? Parametric always has equal groups and non-parametric is going to have unequal groups. Okay, so parametric is going to have equal groups, non-parametric is going to have unequal groups. Now, parametric, it's always going to be a homogeneous distribution. Homogeneous distribution means equal distribution of the population, and they're going to typically be represented by a bell-shaped curve. That is a normal distribution, homogeneous distribution, whereas non-parametric is not going to have homogeneous distribution. It's going to be heterogeneous, and your data is going to be skewed. Your shape is going to be skewed. So it's like it's basically heterogeneous, means randomly, it's not together. Okay, so that's when it's all together, it's homogeneous, similar data. If it's not similar, it's going to be heterogeneous. So parametric, always remember they're stronger tests. It's always going to be equal groups. The dependent variable will either be interval or ratio. Okay, and that's your parametric. Okay, whereas your non-parametric, it's nominal and ordinal. They are weaker. They cannot be generalized to the population. They have unequal group, and the distribution is going to be skewed. Is this clear? Is everyone clear about what is parametric and what is non-parametric? Okay. Now we are going to talk about, in this, depending on, okay, if it's two tests, if it's two groups, it's three groups, we have to know this table very, very well. Okay. So, just to clear first graph, whatever side is the tail is going to be the side of the skewness here. So if the tail is to the right, yes, it's a right-sided skewness or a positively skewed curve. If it's to the left, it's going to be a left-sided skewness or a negatively skewed curve. Okay, now the next one is going to be your main difference, like different type of tests that we use. So one test that we're going to compare the test that we use in parametric, compare the test we're going to use in non-parametric. So let's put parametric here and let's put non-parametric here. Okay, now if you have two groups, and those two groups are independent groups. So two independent groups, that means, can I say they would be equal groups, or at least the dependent variable will either be ordinal or will either be interval or ratio? because it's under parametric? Yes. Now, when I say two independent groups, what did I tell in last class? What do we mean by independent? Two completely separate groups. Let's say group, you have 30 people, they're divided into 15 in group A, 15 in group B. They are not connected. They're given group A, group B, and they both are given separate intervention. Either one is a control group or it's given a separate intervention. That's going to be your two independent groups. Everyone understands what is independent group? They are not related. They are two separate, like there are 15 separate people in group A, 15 separate people in group B. Group A and group B are exposed to different things. These are called as two independent groups. Okay. What is dependent group? 30 people in group A, same 30 people in group B. Okay, first the group A will be given like tenths, then the group B will be given ultrasound. Let's assume that way. But if it's the same people who are given different modalities, what is that called? Or given different kind of intervention. If the same group is there and that same group is be called as group A, group B, group C, then it is going to be your dependent groups. Understood everyone? What is independent group? What is dependent group? Independent group means they are going to be in two completely different groups. Different people are in group A, group B. Dependent group, same people are going to be in group A and your group B. They are called as match samples. Match, that means I'm the same person in group A, I'm in the same person in group B. Make sense? If you have two independent groups and the data is parametric, like if you have everything parametric, what is the test that we use? We use an unpaired t-test. Very good. We use an unpaired t-test. Excellent. Now, if you have two groups that are dependent, okay, you're doing group A, group B, and these are dependent groups, you use a paired t-test. Okay, you use a paired t-test. Very good. Now, this paired t-test can either be one-tailed or it can be two-tailed. So you can have a one-tailed t-test or you can have a two-tailed t-test. What do I mean by one-tailed, two-tailed? One-tail means it's directional. It has a bias. Okay, so for example, I will tell you that if you attend the mega class, you will have an improvement in the score. Do I have a bias? Yes, means your score is going to improve. I'm telling you that my score is going to improve. But if I tell you that on attending the mega class, your score will change. I'm not telling you whether it's going to improve or it's going to decrease. I just say your score will change. Can it be either? Can it be on both the sides of the curve? It could be either improve or decrease or not improve, right? So that's called as a two-tail. So one-tailed is always directional. You always know what's happening. And two-tail is okay. There is a change, but it could be either good or it could be bad. It could be either positive. It could either be negative. That's going to be a two-tail test. Okay. Is everyone clear? Two independent groups, we use an unpaired t-test. Two dependent groups, we are going to use a paired t-test. Okay. Now, if I have three independent groups, let's say I have three independent groups. Let's say there are 10, 10, 10. There are 30 people and 30 are divided into 10, 10, 10. 10 are given exercise, 10 are given aquatic training, and the other 10 are given bike training. So they are all basically three independent groups. What do we use? Anushka, the difference between the paired and the unpaired, the paired is going to be for two dependent groups and the unpaired is going to be for two independent groups. That's it, that you need to know. Okay, three independent groups, the test that we use is going to be ANOVA. Okay, sometimes they say one-way ANOVA, sometimes they say two-way ANOVA, sometimes they say multifactorial ANOVA. We don't need to go into detail of that, but I just want to tell you factor means independent variable. Okay, that's why sometimes they say one-way ANOVA, that means there is one independent variable. If they say two-way ANOVA, there are two independent variables. If they say multifactorial ANOVA, means there are more than three independent variables. But you don't need to bother about that. You just need to know, depend on the groups. If there are three or more groups, it's always going to be ANOVA, right? If there are three or more groups, it's going to 3 or more independent groups, it's going to be your ANOVA. Make sense? All right. Okay, so 2 independent groups, unpaired t-test. 2 dependent groups is going to be paired t-test. It could be one-tailed or it could be two-tailed. 3 independent groups is going to be ANOVA. Now, if you have 3 dependent groups, okay, if you have 3 dependent groups, what is that called? 3 dependent groups means there are 30 people. Same 30 people are given bike training. Same 30 people are given aquatic training. Same 30 people are going to be given normal aerobic exercises. So you have 3 dependent groups. Now for that, you have repeated measures ANOVA. Do you remember our repeated measures design or the within subject design that we had done? Exactly. So this is easy to remember. Just put repeated measures because you know they are dependent groups, and it's going to be called as a repeated measures ANOVA. Is this about parametric clear? So when I'm going to repeat it, when you have 2 independent groups, okay, that means group A, group B, okay. Okay, no, Manasa, that is different. Okay, we will come to hypothesis later on. Okay, right now we're just talking about the test. Okay. So 2 independent groups, it's going to be group A, it's going to be group B. Okay, so that's when you use an unpaired t-test. When you have 2 dependent groups, okay, when you have 2 dependent groups, you're going to use the paired t-test. Your paired t-test is going to be one-tailed and it's going to be your two-tailed, depends. Okay, if there are 3 independent groups, we use the ANOVA, and if there are 3 dependent groups, we use the repeated measures ANOVA. Clear, everyone? Now, what is correlation? Remember, I told you correlation is not a cause and effect. It is just a correlation between the 2 variables. So there is a coefficient for correlation. Okay. For parametric, the main coefficient for correlation is going to be your Pearson's correlation coefficient. Okay, when I do correlation, we will talk about it again. But parametric typically uses Pearson product correlation coefficient, and non-parametric uses Spearman's rho. Okay, now non-parametric, 2 independent groups. If you have 2 independent groups in non-parametric, means your data is either nominal or ordinal. What will be the tests that you use? 2 independent groups, you can either use a chi-square or you can use Mann-Whitney. How will you decide whether to use a chi-square or a Mann-Whitney? Chi-square is for your nominal, Mann-Whitney is for your ordinal. Okay. All right, so then it's going to be your Spearman. Then it's going to be your Spearman's rho. Spearman's rho is your correlation coefficient I told you for your non-parametric. We'll talk about that in detail later. Now let's go to 2 dependent groups. So 2 independent groups, I'm going to repeat. If your data is going to be nominal, okay, if your data is going to be nominal, it's going to be a chi-square that you're going to use. If your data is going to be ordinal, it's going to be your Mann-Whitney that you are going to use. Okay, Mann-Whitney, and it's going to be a chi-square. Okay, now if you have 2 dependent groups, then which one do you use? This one is not commonly heard. Okay, this one's not really commonly heard, but it's going to be, if it's ordinal data, then you're going to use your Wilcoxon signed ranks test. For nominal, it's going to be McNemar. If you don't remember the McNemar one, okay, if you don't remember the McNemar one, It's okay because I've never seen questions asking you about McNemar test, but Wilcoxon sign rank is something you want to remember. Okay. Again, if it's two independent groups, non-parametric, let's say they give you a question, can you tell what is the best test for two independent groups, non-parametric? They don't mention nominal, they don't mention ordinal. What will you give? I said two independent groups. I said two independent groups. Mann-Whitney. Perfect. You're going to use your Mann-Whitney. All right. So always remember, if they tell you there are two independent groups, if they tell you two independent groups and they tell you chi-square, I mean, if they tell you two independent groups and they tell you nominal, then you pick chi-square. If they tell you ordinal, then you pick Mann-Whitney. If they tell you nothing, you still pick Mann-Whitney. Clear? Now, if you have two dependent groups, okay, if you have two dependent groups, all right, if you have two dependent groups, you're going to use Wilcoxon sign ranks test. I doubt they will ask you McNemar, but if it's nominal, it is McNemar. If it is ordinal, it's going to be Wilcoxon sign ranks test. If you don't remember this McNemar, it's okay, but don't forget Wilcoxon sign ranks because that is important. Okay, so if they tell you non-parametric, two dependent groups, what will you say? Non-parametric two dependent groups, what will you say? Wilcoxon sign ranks test. Perfect. Okay. Now, three independent groups, non-parametric. Three independent groups, non-parametric. K-Wallace. That is Kruskal-Wallis. Okay. So it's going to be K-Wallace. And if you have three dependent groups, non-parametric, it's called as Friedman's ANOVA. Okay, it's called as Friedman, F ANOVA. I'm going to type it here. Sorry, let me put it here. It's called as Friedman's ANOVA. Okay, this one was a repeated measures ANOVA. You remember this was a repeated measures ANOVA. This is going to be called as Friedman's ANOVA. All right. Everyone clear? Perfect. All right. Great. We want to do a quick recap of this. Tell me, okay, without seeing on the screen, tell me two independent groups, non-parametric. What do we use? Two independent groups, non-parametric. Mann-U. Very good. I did not mention nominal or ordinal. If I say nominal, it's going to be your chi-square. If I say ordinal, it's going to be your Mann-Whitney. Two dependent groups, parametric. Two dependent groups, parametric. Petty test. Okay, petty test. Good. Three independent groups, non-parametric. Non-parametric, I said. K. Wallace, good. 3 dependent groups, parametric. 3 dependent groups, parametric. 3 dependent groups, parametric. Repeated measures ANOVA. If I say 3 independent groups parametric, it will become ANOVA. Depending on the number of independent variables, it will be the one way, two way, but it will be only ANOVA. But if I say dependent group, then it is going to be repeated measures ANOVA. Okay. 3 dependent groups non-parametric. Friedman's ANOVA. Very good. 2 independent groups non-parametric. 2 independent groups non-parametric. 2 independent groups non-parametric. 2 independent groups. Until I don't get everyone typing the same answer, I'll keep saying the same thing. Manu Whitney. Why did I get Wilcoxon? Wilcoxon is going to be dependent. Who said Kruskal-Wallis? That's going to be 3. Okay, so remember, always make your own table like this. Have a difference, parametric, non-parametric. 2 independent non-parametric, Manu Whitney. 2 independent parametric, unpaired t-test. 2 dependent non-parametric, Wilcoxon sign rank. 2 dependent parametric, paired t-test. Okay, then 3 group. 3 independent group parametric, ANOVA. 3 independent group non-parametric, Kruskal-Wallis. 3 dependent groups parametric, repeated measures ANOVA. 3 dependent groups non-parametric, Friedman's ANOVA. So just have a comparison table. Make that comparison table. You don't remember it, stick it somewhere. But all you got to do is make this small table and stick it somewhere, and you have to remember it. Everyone clear now with the parametric, non-parametric? Awesome. Okay, now that is amazing. Okay, now this is going to help us solve questions. My questions are going to be a little trickier. Okay, I have like I'm going to tell you questions. It's going to be a little trickier. But first question, I'm going to tell you how do we decide what is parametric, what is non-parametric, and how do we decide the test. Okay, but before that, tell me, what was the nominal ordinal that I told you? What am I supposed to look? What am I supposed to look to identify whether it is an interval or ratio, to identify whether it is nominal or ordinal? What am I supposed to look at? Very good. I'm supposed to look at the dependent variable. Okay, good job. Okay. Can I say you guys know this table? I will come back to this table if you need it. Like we will, like in case you want to refer to it when we are doing the question, we will come back to it. Okay. Now let's put a question that says, okay, we'll go step by step. We'll always follow steps so that we don't go wrong. Okay. Let's say there's a question that says, a teacher is measuring, okay, there is a teacher. She's measuring a group of, okay, a teacher is measuring group of 12 children. Okay, she's measuring a group of 12 children and doing squats. Okay. She wants to say that this is a little tricky question, but I want you to understand, which is why I'm giving you a difficult question. Okay. A teacher is measuring a group of 12 children performing squats. Okay. That's what the teacher is doing. She wants to see, okay, is there any change in the number of squats that she performs? Okay. She wants to see, is there any difference in the number of squats they can perform, the children can perform when it is morning or when it is evening? Like, so there are 2 times of the days. Okay. So the same 12 people, the same 12 children. See, a teacher is measuring a group of 12 children doing squats. She wants to see that is there any difference in the number of squats done by the children in the morning or in the evening. So there are 2 groups, right? One group she's checking in the morning, one group she's checking in the evening. She's checking the number of squats. But is it the same 12 people in each group, or is it different 12 people in each group? Same 12 people have been checked in the morning. Same 12 people have been checked in the evening. So first thing, tell me, is it a dependent group or is it an independent group? It is it is two dependent groups, right? Clear? Perfect. That we know it is two dependent groups. Second thing, nothing has been given to me about if there is an equal number or nothing. Okay, so I want to identify whether this is a parametric or a non-parametric. What is my dependent variable here? What is my dependent variable? What is the dependent variable, not the group? What is the dependent variable? Teacher is measuring 12 children doing squats. Number of squats. Now it's just a number. So what is number? Is it nominal, ordinal, interval, ratio, number of squats? It's a number. It's a rank. It's not nominal. Is a rank ever a nominal? It's basically your ordinal because it's just rank. Does the number of squats have equal intervals? No, maybe you're doing 2 squats fast, 3 squats slow. So this is going to be a ordinal. Okay, so this is number of squats is going to be an ordinal. So if my dependent variable is an ordinal, what do you think is my test? Is it a parametric test or is it a non-parametric test? So it's a non-parametric test. So I have come up to 2 conclusions, okay? That I have 2 dependent groups and a non-parametric. Based on the tests that we did previously, based on the table that we did previously, what is 2 dependent groups with non-parametric? 2 dependent groups with non-parametric. 2 dependent groups with non-parametric is going to be Wilcoxon signed ranks test. Okay, it's going to be Wilcoxon signed ranks test. Good? Everyone understood why we did that? We just wanted to make sure we have to identify. So not always in your exam, they will give you equal number of groups or no. So if they don't give you equal number of groups, how will you identify whether the test is parametric or non-parametric? You look at the dependent variable, identify, is it nominal or is it ordinal? Or is it interval or is it ratio? Clear? Now the next one, you will do it. Follow the steps and then do it and then we will discuss, okay? Next one is there are 40 elderly residents. Okay, so there are 40 elderly residents and they have been divided into 2 groups of equal numbers. So they are divided into 20 residents in group A and 20 residents in group B. Group A has been given, let's say, aquatic exercise plus normal aerobic exercise. And group B has only been given aerobic exercises. Okay, so you want to check the difference in the strength on a Cybex machine. That means Cybex machine is a machine that helps us measure the strength. You want to see if there is any difference between the 2 groups on the strength on a Cybex machine. So go step by step and tell me what should the test be, what test should be done. It's going to be unpaired t-test. Okay, it's going to be an unpaired t-test. Perfect. Why unpaired t-test? Why did I say parametric? Because equal group. There are 2 ways of saying parametric. One, you have equal groups, 20 and 20. And the other one is the dependent variable is the strength on a Cybex machine. Is this strength on an MMT? No, strength on MMT is ordinal, but this is a strength on a Cybex machine. Cybex machine is like an isokinetic machine. So it's going to be very accurate. It's like digital. So that's mainly like a ratio. Okay. So you already know based on equal group that it is parametric. Okay. Now you have two independent groups and parametric. What is the test that we use for two independent groups and parametric? It's going to be the unpaired t-test. Is that clear? Okay. Want to do one more question? Okay. There are a group of 15 children with cerebral palsy. Okay. There's a group of 15 children with cerebral palsy. Okay. You want to check, like basically you are checking the gait. You're checking the gait of these 15 children at slow speed, at fast speed, and moderate speed. Okay. And you are taking their scores on, and basically you are asking them to walk at slow speed, at moderate speed, and fast speed, and you're marking their scores on a Trinity-Poma scale. Okay, your Trinity-Poma, which is your balance and your gait subsection score scale. So your Trinity-Poma scale is where you are evaluating these kids. Okay, so you have 15 children with cerebral palsy. They are walking at slow speed, they are walking at fast speed, and they are walking at moderate speed. So 15 children, slow speed, fast speed, moderate speed. Okay, and it is on a Trinity-Poma scale they are checking. Okay, they're checking on a Trinity-Poma scale. So tell me, what should, like, you want to compare if the scores are changing at slow speed, at fast speed, and moderate speed. What do you think it should be? Oh, that's good. Okay. Is it a dependent group, independent group? Dependent group, because same 15 children are in group A, group B, group C, right? What is the dependent variable? Is it ordinal, nominal, interval, ratio? Ordinal. So now you have three dependent groups, non-parametric equivalent. What is a three dependent groups non-parametric equivalent called? Friedman's ANOVA. Okay, you guys are amazing. You guys got it so quickly. That's good. Wow. All right. Okay, let's do one more. Okay, there are 30 people, 30, thank you. We have 30 people with ACL tear. Okay, we have 30 people with ACL tear. Let me write it down here. 30 people with ACL tear. Okay, now 10 people are given walker. 10 people are given cane or crutch. Okay, and 10 are given a cane. So 10 walker, 10 crutch, 10 cane. You want to see if there is any difference in the distance covered by them with a walker, with a crutch, or with a cane. Tell me, what should I use here? I'm going to use my normal ANOVA. Why? Because it's three equal groups. That's one way of identifying parametric. And the other way is distance. What is distance? If you say distance covered, what is the dependent variable? Is it nominal, ordinal, interval, ratio? It's a ratio. So you have parametric and you have independent group. So three independent group with a parametric equivalent is your ANOVA. Good. So now if you get, I gave you guys difficult questions, okay? So now if you get a question whether to identify independent t-test, whether to identify t-test, or whether to identify ANOVA, will you be able to identify these tests, whether it's Mann-Whitney, Kruskov-Wallis? All outcome measures are ordinal. That's correct, Divya. Okay, so you feel confident about this now? First thing I want you all to do is make this table, memorize this table. Independent groups 2, 2 dependent groups, 3 independent groups, 3 dependent groups, parametric and non-parametric equivalent. Okay. Then always go step by step. Identify, is it independent group, dependent group? Identify if it is parametric, non-parametric, and identify the number of groups. If you can identify this from the question and you know this table, you're going to get these kind of questions correct. Good. Awesome. Next thing that we're going to talk is your correlation. Okay, let's talk about what is a correlation. Okay, now I kept on saying correlation even before. I kept on saying correlation coefficient, but I never really explained you what was correlation. Now, what is correlation? Correlation is basically when you are identifying a relationship between the two variables. So when you identify a relationship between the two variables, that's going to be called as correlation. Okay, relationship between the two variables. Now, if we look at this, let's say, okay. Now, if we look at this, that's going to be a positive correlation. We have a negative correlation and no correlation. Okay. Now, first, I want to tell you, correlation is not a cause and effect. It is only that there is a relationship between the two variables. Now, correlation can be positive or correlation can be negative. When it is a positive correlation, okay, when it is a positive correlation, it's always going to be a direct relationship. Okay, directly proportional. You can say directly proportional. If it is a negative correlation, it's going to be inversely proportional. A little bit of math here. Okay. Now, what do I mean by directly proportional? Let's say I am looking at the correlation between two variables. What are my variables? Let's say heart rate and blood pressure. Okay. If I say that heart rate, okay, if I say that heart rate and blood pressure are directly correlated, I mean, are positively have a positive correlation. What does that mean? Heart rate increases, blood pressure increases. That is a positive correlation. Heart rate decreases, blood pressure decreases, positive correlation. If I say heart rate and blood pressure have a negative correlation, it is going to be opposite. So that means if heart rate increases, blood pressure decreases, or if heart rate decreases, blood pressure increases. Understood what is the meaning of a positive and a negative correlation? Correlation means the relationship between the two variables. It is not a cause and effect. It can either be a positive correlation or it can be a negative correlation. Positive correlation, directly proportional, both increase, both decrease. Negative correlation, inversely proportional, one increases, other decreases, this one increases. Okay, that's a inverse relation. Now, how do you determine if the correlation is strong or is weak? So you have some values, okay? High correlation. What is high correlation? High correlation is always 0.75 and up. Okay, so anything that is 0.75 and up and higher, okay, 0.75 and higher is going to be your high correlation, okay? Then your moderate correlation is going to be 0.5 to 0.75. Okay, so 0.51, basically 0.51, 2.7, this is 0.76. I should rather put 0.76 and higher. Okay, this is going to be 0.51 to 0.75. That's going to be your moderate correlation. Okay. Below this, you have fair and you have low. Fair is 0.26 to 0.50 and low is 0.00 to 0.25. But below this, below moderate correlation, generally you will just consider that, okay, it's not at all, it's weak. It's very, very weak. Okay, so moderate is still okay. It's moderate, but fair and low, that's all like below 0.50. It's considered to be very bad correlation. Okay. So now, does it depend whether it is positive or negative? Does that determine the strength of the correlation, whether it is positive or it is negative? No, it never determines the strength of the correlation. What is the strength of the correlation? The closer it is to 1, stronger is the correlation. So if my correlation is 0.99, it's very strong. If it is negative 0.99, it is still very strong. It's just that now they are going to be inversely related. If it's negative 0.99, if it's positive 0.99, that means they are strongly positively correlated. Negative 0.99 is a strong negative correlation. 0.99 is a strong positive correlation. Clear? So correlation can be positive, correlation can be negative. Positive is directly proportional, negative is inversely proportional. If you have a closer to 1 is considered high, does not matter whether it is positive or negative, the more closer you are to 1, that's going to be high correlation. 0.76 and above is going to be considered high. 0.51 to 75 is going to be considered as moderate correlation. Anything below that is considered low. Is so much clear in correlation? Now, what is a graph of a positive correlation? Strong positive correlation. Now, this is the value of R, okay? Whatever we are talking is R. This is called as a correlation coefficient. So R is equal to 0.76 and higher. R is equal to 0.51. So R is your correlation coefficient. For parametric, what is this R? It's called as a Pearson product correlation coefficient. For non-parametric, what is this R called? This is called as your Spearman's rho correlation coefficient. Okay, clear? What is a strong positive? How does a strong positive correlation look like? Strong positive correlation look like a straight line that's going towards the right. So it's going to be like this. If I have a correlation that is like this, what is this called? This is called as a strong negative correlation. If I have a horizontal line, what is that called? No correlation. If I have a correlation that looks like this, what is that called? Weak positive correlation. If I have a correlation that looks like this, little bit slopey, weak negative correlation. Okay, so remember correlation can be positive, negative. The closer it is to 1, higher is the correlation. Whether it is positive, negative, doesn't matter. Positive, direct proportional. Negative, inverse relation. Okay, these are the graphs they can show you in the exam, that if something increases, if it's going towards the right, it's going to be positive. It's going to the left, it's going to be negative. And horizontal is no correlation. These are strong positive, weak positive, strong negative, weak or negative correlation. Is this clear? Now there's something which is called as a regression. Okay, regression analysis. Okay, there is something which is called as a regression analysis. Now, correlation is just a relationship between two variables. If heart rate increases, blood pressure increases. If blood pressure decreases, heart rate decreases. Does it tell you by how much? Does it tell you that, okay, can correlation tell you if my heart rate is increasing by 10, my BP will increase by 20? No, correlation never tells you by how much. What tells you by how much is your regression analysis. Regression is just having an equation. Okay, it's a formation of an equation. Regression analysis and formation of an equation which helps us identify like by how much is that person, like by how much is it correlated. That is going to be your regression. Okay, so it tells us by how much is the correlation there. Okay. Now, let's say, let me give you an example. Okay, now let's correlate. Okay, let's correlate your PEAT scores, okay, and your NPT. So if I say PEAT and NPT have a positive correlation, what do I mean by saying PEAT and NPT have a positive correlation? That means if you pass the PEAT, you pass the NPT, right? Or if you fail the PEAT, you fail the NPT. That is the meaning of positive correlation. But you see your PEAT scores. Have you guys given the PEAT? Have you seen that thing where they say on track to passing and then they say your estimated NPTE range? Do you read that where they say your estimated NPT range? So they're not just doing a correlation, they also did a regression analysis. That means they have an equation that they formed. Based on that equation, they can tell you by how much is going to be your correlation, like by how much is you are going to increase. So they give you a range that, okay, if you scored so much in the PEAT, then your score on the NPT is going to be this much to this much. Understood the difference between correlation and regression? Correlation is just telling that, okay, if something is increasing, something is, whether it is positively correlated or whether it is negative correlated. But regression analysis tells you how much, which is why there is an equation that is formed, and that equation is called as regression analysis to tell you by how much you can predict the correlation. Okay. Yes, that's correct, Dolly. It is your capital R. Okay. Is this clear? Everyone clear with what is regression analysis? What is correlational analysis? Okay. Let's do a question on this. Okay. Before we do a question, Pasha, I think you had a question which was based on parametric, non-parametric. Okay. So I want you to send that question on the group again. So let's try doing that question. Okay. So we know whether we know our things or no. You send the question, everyone solve it, and then I'll discuss it. Okay. After we solve the question, we're going to solve something more, but for now, let's solve the question that Pasha sent. Okay, with physical type is examining differences among repeated measures and subjects within the same. Okay, this question really does not tell us anything about the groups or anything. Here you can easily use elimination strategy. What is it at least telling you here? Whether it is dependent group or independent group. What do you find out in this question? It tells you dependent group, right? Now, does it tell you whether it is parametric or non-parametric? Are you able to identify whether it is non-parametric or parametric? Non-parametric. All you need to identify which test in the above question is non-parametric as well as using dependent group, which is the only one up there which is using dependent group and non-parametric. Friedman's ANOVA. Why is chi-square not correct? Because chi-square does not use dependent group, does not use a repeated measures thing. It uses independent group. So your answer is going to be Friedman's ANOVA. Got this one? Good job. I told you, wait for the class, you'll get it. All right. Now, the next table that I sent you, okay, the next table that I sent you was your correlation statistics, okay? Now, looking at the correlation, why not Spearman's? Because Bethel-Spearman's is a correlation coefficient. There's nothing mentioned about correlation coefficient, okay? There is absolutely nothing mentioned about correlation coefficient here, okay? Nothing mentioned about correlation of the data. Nothing like that is getting mentioned here. So that is why you're not going to use your correlation statistic. You cannot use your Spearman's. They asked your statistical test. Perfect. Okay. Now, the next thing that you see, your correlational statistics. Do you see that picture which says correlational statistics? Okay, so it tells you your weight, it tells you your height, it tells you your BMI, and it tells you your height. Now tell me, okay, let's see how to read this table. Okay, you have your height, weight, and BMI. Okay, this is your height, weight, and BMI. And again, here you have your height, weight, and your BMI. Okay, so it has your weight, BMI, and your height. Okay. Why is non-parametric in that question? It says it is not normally distributed. So if you read the second line of the question, it says that it is not normally distributed. Now it says that the weight is 1.80 and 0.5. Okay. Okay. Now tell me, what is the correlation between weight and BMI? Based on this table, tell me the correlation between weight and BMI. Means you look at weight and you look at BMI. What is it? It is 0.80. That means it's a strong positive correlation. So if it's a strong positive correlation, what is happening? What do you mean by strong positive correlation? If weight increases, BMI increases. If weight decreases, BMI decreases. What is the correlation between weight and height? It's a very poor correlation, right? So that you cannot really interpret that that's going to happen. So it's a very weak positive correlation. What is the correlation between BMI and height? Again, it's going to be moderate correlation, right? Moderate correlation is something that is 0.5 to 0.75. So it's going to be your moderate correlation that we are going to see. Okay, so that's going to be your moderate correlation. It's going to be inversely related. So everyone knows how to read this table for correlation. So whether if they ask you BMI increases, height increases, what happens to the weight, weight increases. So you just look at the correlation and identify, is it a direct relation? Is it an inverse relation based on the sign that is given? Always remember, more it is closer to 1, it is going to be a strong correlation. Good, clear with correlation? In Beatrice, in Pasha's question, it said that the patient is the groups are a repeated measures design, which means you are testing on the same patient, on the same group of patients, and they have told you that the data is not normally distributed. If the data is not normally distributed, you know it is a non-parametric test and it is a dependent group. So the only option in that question with dependent groups as well as non-parametric was Friedman's ANOVA, because the other options were chi-square, which was for independent groups. Spearman's rho is the one that we use for. Spearman's rho is something that we use for correlation coefficient and not for your, not for the statistical test. Okay. Are they correlation value? Yes, Priyanka. What I'm teaching right now here, this is a correlation value. Okay. Now, again, there are these 4 correlation coefficients that we use. Okay. There are 4. Only 2 of them are very important, but we have 4. Which are the 4? One is Spearman's. One is Pearson product. So we have 4. One is Spearman's correlation. One is Pearson product correlation. Which are the other 2? Very good. Point by serial. And again, those are not the common ones, but we should know them. Okay, so you have your Pearson product correlation coefficient. You have your Spearman's rho correlation coefficient. you have your point by serial, and you have your rank by serial. Okay. Now, if it's a Pearson product, that means this is a correlation coefficient that is parametric. It is correlating both variables which are either ordinal, which are either interval or ratio. Why did I say interval or ratio? Because it is a correlation coefficient that is for your parametric. So your variables, if they are interval or ratio, then what is the correlation coefficient you use? You use a Pearson product correlation coefficient. If both your variables are ordinals, if both variables are ordinals, what do we use? We use the Spearman's rho correlation coefficient. What is an example of ordinal? Let's say I'm trying to see the correlation between MMT and let's say between MMT and work balance scale. What is the correlation coefficient that I use now? It's going to be Spearman's rho because both my variables are going to be ordinal. Okay. For Pearson product, both my variables have to either be an interval or a ratio. For Spearman's rho, both of them have to be ordinal. For point by serial, one is going to be, what is going to be, one variable is going to be parametric. That means it's going to be either interval or ratio. Yes, Anushka. Spearman's is for non-parametric. If we see here, we've written ordinals, right? If we see here, we've written interval and ratio. So based on that, we know parametric is Pearson's. Spearman's rho is your non-parametric. Point by serial means one variable is interval or ratio, and the other variable is, what is the other variable? It's nominal. Okay, so one of the variable is just going to be a category or something nominal, and one of the variable is going to be interval ratio. I will give you one question on this so you're able to identify. And rank by serial means one variable is nominal and one is ordinal. Okay, so there are four types of correlation. There are four types of correlation coefficient. Okay, you have Pearson product correlation coefficient, you have Spearman's rho correlation coefficient, you have point by serial and rank by serial. Pearson product means both your correlation coefficients, are going to be a parametric data. Okay, so both of them are going to be the interval or ratio. Spearman's rho means both your variables are going to be ordinal in nature. Point by serial means one is going to be interval or ratio and the other one is going to be nominal. And rank by serial is one variable is nominal, one variable is ordinal. Is that clear? In your exam, they typically focus on these two. So if they say parametric, if they say what is a correlation coefficient for parametric test, we are just blindly going to put Pearson product. If they say what are the correlation coefficient for non-parametric tests or for non-parametric data, it's going to be Spearman's rho. Okay, these are the most common two that we need to know. But we also know what is point by serial and rank by serial because this is there in your books. Point by serial is one interval and one nominal. That means one of the parametric variable and one of the non-parametric variable. Whereas rank by serial is one variable is nominal, one variable is going to be ordinal. Is this clear, the four types of correlation coefficient? Perfect. Okay. Let me send you a question so you are able, let me see if you guys can apply that question. Okay. What does the question say? Dependent variable is a knee valgus force, okay? And the independent, so what is a valgus force? What is a valgus force? Is it nominal, ordinal, interval, ratio? It's a force. What is force? Force is a ratio. And the independent variable, so they're telling you, okay, that it is your, the other one is your gender, that is your nominal. So if you have one, that is your valgus force, and the other one, that is your nominal, what is going to be the one between your ratio and your nominal? That's going to be your point by serial one. Okay, so your C answer. Okay, because one of the variable is nominal, one of the variable is your ratio. Clear? Usually in the exam, I've always seen questions related to Pearson product and Spearman's rho. Good job. So that was about your correlation. Everyone clear about this? Okay. Now the next part that we are going to go on to, that is going to be called about your statistical test. Okay, that's mainly your hypothesis, your test, when it is called statistically significant. That is what we are going to do next. Okay, so this is going to be an important part. I want you all to focus. So far, everyone good? Everyone good between parametric, non-parametric, the types of tests that we use, and correlation also, correlation, regression, parametric, non-parametric, perfect. Okay. Now this is the first thing I want to start with. What do we know? What do we understand by the term hypothesis? Hypothesis is an assumption that is made. A tentative assumption that we make is called as a hypothesis. Okay. So a tentative assumption that we made, okay, that we can test, that is called as a hypothesis. Now, hypothesis can either be a, so let's say experimental hypothesis. Okay. Let's say experimental hypothesis or alternating hypothesis. This is one kind of hypothesis. So experimental or alternating hypothesis. What does this mean? This is basically an assumption. It is what you're assuming, that is the relationship between the variable. So let's say you have an assumption. Let's say you want to do a study. You want to do a study on a person with, by giving them, let's say, hold, relax, contract, relax. You want to do a study where you are assuming that hold, relax, contract, relax is going to increase the range of motion. So what is your alternating hypothesis? Your alternating hypothesis is going to be that hold, relax will improve the range of motion, right? Because that is an assumption you are making. You could make any assumption. Whatever study you want to do, if you think that's going to happen, that's going to be your experimental or your alternating hypothesis. Okay. Now, experimental alternating hypothesis can also be directional, non-directional. Same way like you had your one-tail, two-tail test, your hypothesis can also be directional and it can be non-directional. Okay, what do I mean by directional? So if I say hold, relax will improve the range of motion, is that directional or non-directional? Directional, because I know it's going to improve. But if I say hold, relax will change the range of motion, there will be a difference in the range of motion after hold, relax technique. What is that? That means there is no bias. It could be either increasing. I just said change in the range of motion, right? I didn't say range of motion will increase or range of motion will decrease. So that's called as a non-directional hypothesis. Okay. So what was hypothesis? Hypothesis was an assumption or a tentative relationship between the two variables. The first type of hypothesis that we have is your experimental or your alternating hypothesis. That is an assumption that you are making of your study. This alternating and experimental hypothesis can either be directional or it can be non-directional. Directional is it will tell you whether something is improving or something is getting worse. Non-direction will just tell you there is a change. That means it could go on either direction. Everyone understood what is an experimental hypothesis or an alternating hypothesis? It is the assumption that you make. Now, the other hypothesis that we know is a null hypothesis. So whatever assumption you have made in the experimental hypothesis, null hypothesis is exactly opposite. So if I tell hold, relax will improve the range of motion in my alternating hypothesis, what will my null hypothesis say? Hold, relax will not improve my range of motion. So exactly opposite to what you are assuming, That's going to be your null hypothesis. So whatever hypothesis you are making or whatever hypothesis you are predicting, that is your experimental hypothesis or your alternating hypothesis. But null hypothesis is exactly opposite, and you tell that there is no relationship between the variables. That is your null hypothesis. Now, which one of them should I call the statistical hypothesis? Is my alternating hypothesis the statistical hypothesis or my null hypothesis the statistical hypothesis? My null hypothesis is the statistical hypothesis. Why? Because I always test in my research, my study that I'm doing, I always test my null hypothesis. What if I reject my null hypothesis? I never say that, okay, I am accepting my alternating hypothesis. What do I say? I am rejecting my null hypothesis. So when you reject your null hypothesis, that means that your study is significant. If you reject your null hypothesis, means your study is significant, and it automatically means that your experimental hypothesis is correct. But this is how research goes. Research never tests the alternating hypothesis. No, research always tests the null hypothesis. If you want your research to be statistically significant, or if you want your experimental hypothesis to be true, you should be able to reject the null hypothesis. Okay. If the null hypothesis is accepted, there is no significant difference between the two treatment, two variables, nothing. If the null hypothesis is rejected, that means there is significant difference between whatever you were testing. Clear? I'm going to repeat again. Hypothesis is just an assumption. You either have an experimental or an alternating hypothesis. That is your assumption of the study. Your assumption of the study is your experimental and your alternating hypothesis. Null hypothesis means there is no relationship between the variables. Okay. Now, in your research, you always test the null hypothesis, which is why we call the null hypothesis the statistical hypothesis. Your main goal is to reject the null hypothesis in order to make sure that your study is statistically significant. Is that clear? Everyone good with this? Understood what is hypothesis? What are the two types of hypothesis? Okay, when do we call that the study is statistically significant? We call it only when you are rejecting your null hypothesis. Okay, now the other thing that is very important. What do we understand by the term alpha? What does the term alpha indicate? What does the term alpha indicate? Nope, alpha is not the p-value. Alpha indicates the level of the significance, okay? Although in your exam, sometimes they just put the p-value there, okay? That's okay. I'll tell you what is the difference between them. Alpha is the set level of statistical significance. What do I mean by set? You set a level of significance. If you set the level of significance to 0.05, it's set. What does that mean? Most of the time, your alpha is always set to 0.05. So whenever it's not mentioned in your question, it always indicates that the alpha is set to 0.05. What does the alpha set to 0.05 mean? Alpha set to 0.05 means that only 5% of your study is happening because of chance. So there is only 5% of error. Now, why do we set alpha to 0.05? You know, whenever you're doing a study, is it possible to get 100% no error thing? Some errors can happen somewhere, right? So you are giving a chance. You are telling you're making sure your study has an alpha that is a level of significance to 0.05. Why? So that it's okay. 5% of your study can be because of chance. Okay, so the error, so it's basically that's because of chance. So in order to help you make mistakes, that little bit of, in order to cover up your mistakes, you are setting the alpha at 0.05. There are studies that set the alpha to 0.01. So alpha is like your, you could say, estimate of expected errors. So if you set the alpha to 0.01, that means how much percentage of error is allowed? That means only 1% of error is allowed, okay? That is why most of the studies have the alpha that is set to 0.05. Very few studies that are very specific only they have their alpha set to 0.01. Let's say if there is something about a drug trial or anything, only their alpha is going to be very high, that is 0.01, so that even 5% error by chance is not there. Okay. So level of significance is your alpha. Most of the time, your alpha is set at 0.05 unless mentioned 0.01. If it's 0.01, that means 1% chance of error is allowed, and 0.05 means 5% chance of error is acceptable. Okay. Now, what is a p-value? A lot of time in your exams, they won't write alpha, they directly give p-value. Okay, sometimes they don't put alpha, they sometimes give p-value. What is a p-value? P-value is a probability value. Okay, basically it's your probability value. Okay, so now so basically it means that 5% probability of error happening. Okay, so p-value is the probability value. Now, for your data to be statistically significant, what should be the p-value? For your data to be statistically significant, always less than the alpha. So whatever your alpha is set to, most of the time in your exams, they won't mention what is the alpha set to. So what should your p-value be? P-value should be less than 0.05. If you see that the p-value is less than 0.05, what does that indicate? That your study is statistically significant. So p-value equal to or less than 0.05. Okay, equal to or less than 0.05 means that your study is statistically significant. Okay, I'm going to repeat again. Alpha is usually called as your level of statistical significance. Okay, alpha is always set. For a study, alpha is always set. That's your level of statistical significance. Most of the studies is going to have alpha set to 0.05. So when it's not mentioned anywhere in the question, you assume that the alpha for this question is 0.05. Unless mentioned that the alpha is 0.01. Okay, unless mentioned that, we always consider the alpha set to 0.05. P-value is the probability that whatever is done is because of chance. It's basically the probability that whatever error that is, like, it's basically your, what could I say, that the probability of error from happening. Okay, that's your p-value. So if that probability of error is less than your level of statistical significance, that is 0.05, that means your data is statistically significant. Think of that probability of error. You want errors to be less, right? So your P should be less than 0.05 or equal to 0.05. If they've told you that the alpha is set at 0.01, then what will your P be? If they've told you that the alpha is set to 0.01, that means your P value is going to be less than 0.01 to be statistically significant. If the p-value is less than 0.05 or less than 0.01, what do we conclude? We conclude that my study is statistically significant, right? So two things I told you. If you're able to so if my p-value is less than 0.05, coming back to it for a second, if my p-value is less than 0.05, what can I say? Can I reject the null hypothesis or can I accept the null hypothesis? Reject the null hypothesis. So that means my data is automatically statistically significant. Okay. So remember, p-value less than the alpha, data is statistically significant. Study is statistically significant. Rejecting the null hypothesis, study is statistically significant. Is this clear? Is this clear so far? Okay. Now, before we go ahead to different ways of how to identify if a study is statistically significant, I want to talk about the type of errors. You guys already know it. So just a quick recap. Your type of errors, you have two types, your type 1 and your type 2 errors. Okay. This is in your study. When you do a research study, you can have a type 1 kind of an error or you can have a type 2 kind of an error. What is a type 1 error? Type 1 error is a false positive error. Okay. Type 1 errors are false positive errors. Okay. What do you mean by false positive error? That means Think about this. You typically tend to make this when you're doing a study. Okay, when you're doing a study, let's say you are in a DPT program and you want to do a study and you want to try and prove something. To prove something, what should you do to the null hypothesis? To prove something, what should happen to the null hypothesis? Reject it. Okay. Let's say in your study, to make sure that your DPT project or your DPT research or dissertation is, to make sure that it is good, because you are tempted that you want to make your study, you want it to be statistically significant. What do? You reject the null hypothesis. But what if you falsely rejected the null hypothesis? That means you rejected the null hypothesis when it was actually true. That means your study was not really showing the results that were supposed to be shown, but yet you went ahead and rejected the null hypothesis. Is this an error? It is an error when you're rejecting something that should not be rejected. That is true. That's why we call it a false positive error. So when you are rejecting the null hypothesis, when it is actually true, that is a false positive or a type 1 error. Should you reject the null hypothesis when the null hypothesis is true? Not really, right? If your null hypothesis is true, you can't reject it. You only reject it when the null hypothesis is false. But if you are rejecting the null hypothesis when it is actually true, you are committing a type 1 error, which is a false positive error. Type 2 error, what is a type 2 error? It's your false negative error. So now you are accepting the null hypothesis, okay? You are accepting the null hypothesis when it is false. So your null hypothesis in ideal, like if the null hypothesis is false, what should we do? We should reject it, right? But you are accepting it. That is a type 2 error. So accepting a null hypothesis when it is actually wrong, when it is false, that's called as a type 2 error. So 2 errors, type 1 error, type 2 error. Type 1 is rejecting the null hypothesis when it is actually true. That's a type 1 error called as a false positive error. Type 2 error is accepting the null hypothesis when it is actually false. So that's going to be a false negative error. That's going to be a type 2 error. Clear types of errors, type 1, type 2 kind of errors. Okay. Type 1, false positive, you reject the null hypothesis when it is actually true. Type 2, you accept the null hypothesis when it is actually false. Okay. Instead of rejecting, you're ending up accepting it. And instead of accepting, you're ending up rejecting it. So that is why it's called as an error. How do we reduce errors? How do you reduce errors in a study? You do a random sampling, very good, random sampling. You use a large sample size. You use blinding, correct? So you're not really, the researcher or the subject does not know the outcome. That's called as blinding. And you use valid measures. Okay, you use valid measures. So valid and reliable measures, accurate instrument. This is how you're going to stop you're going to stop these errors. Okay, so false positive, rejecting the null hypothesis when it's actually true. False negative error, that's your type 2 errors, is accepting the null hypothesis when it is actually false. So these are your two types of errors: false positive, false negative, type 1, type 2. To avoid that, we are going to increase the sample size. We're going to do random sampling. We will use valid measures, and blinding can also be done. Okay, makes sense? Do you know what is type of errors? Do you know what is alpha? Alpha is the level of statistical significance. So if you want a study to be statistically significant, your p-value should be less than the alpha. Okay. Now, another way. So now we are going to go over 3 ways. Okay, now, sometimes you get tables in your exam. Your tables ask you whether the data is statistically significant, whether the data is not statistically significant. So we are going to learn how to read a table. Okay, so 3 ways Three ways to identify statistical significance. What is the first one that we did? P-value. What should the p-value be? P-value should be less than 0.05 or it should be less than 0.01, depending if they mention that the alpha is set to 0.01. The other way of identifying statistical significance is critical value. Okay, every study that you do, every research that you do, that particular, when you're comparing these tests, each one of them have a critical value. Okay, the critical value is fixed, it will be given to you. You don't need to memorize critical value for any test or anything, but that's going to be, you will be given a critical value. Okay, and then you have a calculated value that will also be given to you. What is a calculated value? Calculated value is, let's say you are doing t-test, you are doing t-test, you are doing ANOVA, you're doing Kruskal-Wallis, any test that you are doing. After performing the test, whatever value you get after performing that test, that is called as a calculated value. Understood? Calculated value is the value that we get after solving the test. In your exam, nobody is going to expect you to solve anything. Both the values will be given to you. Okay. The critical value will also be given to you. The calculated value will also be given to you. Okay. So calculated value is the value that is obtained after your statistical test. Critical value is always the one that is going to stay fixed for a particular study or a particular test. Okay. For your data to be statistically significant, which one should be higher, calculated or critical? Calculated value should be higher than the critical value. Okay, your calculated value should be higher than your critical value in order to tell the data is statistically significant. Okay, so your calculated value should be higher than your critical value in order to say that the data is statistically significant. Okay, now for example, if your calculated value is 5, okay, if your calculated value is 5 and your critical value is 3, okay, if your calculated value is 5 and your critical value is 3, is the data statistically significant? Yes, it is statistically significant. Okay, you can reject the null hypothesis. Somebody asked me, what is calculated value? Calculated value is the value that you attain after doing your test. Let's say you did the t-test, or let's say you did the t-test, or you did the ANOVA, or any test that you did, that is going to be your calculated value. Okay, good. So when the calculated value increases the critical value, okay, when your calculated value is higher than the critical value, that means your test is statistically significant. I am going to send you a question. Critical value is a value. So, Bethel, critical value is a value that is fixed. Okay, it's a value that is fixed. That's not going to be changed, and that is usually not nobody expects you to memorize it. Okay, it is basically, I can tell you, it's a point in your test distribution. So in your bell-shaped curve, it's basically a point on the test distribution that is compared to the test statistic value. So that is your critical value. It will be fixed. It will not be asked to be calculated. Okay. Okay. So if, let's say, just to tell you, if this is your bell-shaped curve, critical value is going to be a point on the curve. Okay, it's going to be a point on the curve that is splitting the two halves. That's going to be a critical value. Okay, that's not something that's going to be changed. It will be given to you. Calculated value is what you attain after performing the test. After performing the test, if the calculated value is greater than your critical value, then you can reject the null hypothesis. Okay. Now let me send you a question related to this. solve that question. Okay. Okay, let's look at the question. It says that the here, see, they've not given you the alpha. If they've not given you the alpha, you're considering it to be 0.05. They've tell you, but here instead of alpha, they use the term p value, and that's okay. Sometimes they will not use alpha, sometimes they will use p instead of that. Okay, but the question here is not about the p. The question here is about the critical value. The critical value is 1.45. What is the calculated value in this? They're telling you the statistical test result is 1.85. So what is the calculated value? Calculated value is 1.85 and the critical value is 1.45. Is the calculated value greater than the critical value? Yes, it is greater than the critical value. So is the data statistically significant? Can I reject the null hypothesis? Yes, you can reject the null hypothesis. So option C and option D is incorrect. Now, what does it mean? Is the chance, whatever chances, whatever error that has happened, is it less than 1% or is it greater than 1%? If your alpha is 0.01, that means whatever error is happening by chance is going to be less than 0.01 seconds. I mean, it's going to be less than 1%, or the alpha is 0.01, or the p-value is set at 0.01. Clear with this question? So now you know two ways how to identify whether the critical value is given in the question. Sarah, if you read the last line, it says the critical value of the null hypothesis is 1.45. So it is given, the critical value is given to you. Okay. Critical value is also given to you. The calculated value is also given to you in the question. So you know two ways how to identify whether a test is statistically significant. One, by checking the p-value. The p-value should always be less than 0.05 or be less than your alpha. If your the second way that we did was your calculated value should be greater than your critical value. If it is not greater, you cannot reject the null hypothesis. Okay. And there is one more way of identifying whether the test is statistically significant or no, by the confidence interval. But I'm going to first send you some pictures. Okay. First going to send you some pictures to read tables. A lot of times we do get questions in your exam that are tabular format. And when we look at tables, we get scared. So we are going to be learning how to read these tables. Okay. Don't worry, they just look weird, but it's very simple to read them. Okay. Thank you, Devanshi. I like when you guys say that you're actually liking a subject. All right. Look at the first table that I sent you. Okay. After the critical value question, the first table that I sent, it says paired t-test. All of y'all, I want you to look at that one that says paired t-test, right? When you get such a table in your exam and they tell you, look at what is written on the left side. So they are telling you that they're comparing range of motion with brace and range of motion without brace. That is what they are comparing. You have to identify whether whatever they're doing is statistically significant or no. So what is the first thing that I told you? We look at the p-value. Here, what do you think is the p-value? What is the p-value here? 0.140. Very good. Looking at this table, what will you say? Is the data statistically significant? No, because P is not less than 0.05, it is not statistically significant. Okay, that's one way we rejected this. Okay, other thing, assume that I told you, okay, let's assume that I told you that the critical value, okay, let me give you a critical value. Okay, I'm telling you that my critical value is 1.89. This is a number that I made up, okay? I'm just telling you the critical value for this particular test is, for this particular study, is 1.89. Okay, this is what I'm telling you the critical value is. Can you tell me what is the calculated value in this table? 1.618. Why? Because can you read T over it? There's a small T that is there. There's a small T and it says 1.618. That means that this is the value that you got after performing the T test. Okay, this is the value that you got after performing the T test. What did I tell you? What is the critical value? What is the critical value for this test I told you? 1.89. What is your calculated value? 1.618. Is the calculated value greater than the critical value? No. Can the study be statistically significant? No. So two ways, you know, if they give you a table and if they want you to identify based on critical value, they will give you the critical value, okay? If they've not given you the critical value, means they're not going to expect you to, they're not going to expect you to, okay? All right, good. But you know how to identify whether the data is statistically significant based on these two things? Okay, the third thing is confidence interval. Do you see that table that says 95% confidence interval? Do you see that thing where it says upper, lower? Now, on the left-hand side, you see a negative sign, negative 0.5176, and the other one says positive 3.1176, right? Whenever your study is statistically significant, this is a way to see in the table, whenever your study is statistically significant, both these signs should be same. If one is positive, one is negative, yes, your study is never statistically significant. Okay, so in your confidence interval, they both should be having the same sign. If it is not the same sign, that means your study is not statistically significant. From a table, not that they will ask you this in the exam, but if they're giving you a table and you're really lost, you're really confused, you're not understanding, you cannot see the p-value or anything, this is another way of also seeing it, that if both the signs are same, the study is statistically significant. If both the signs are not same, it cannot be statistically significant. Okay, so now you know 3. Okay, now you know 3. Agreed, you know 3 things. One is p-value. P-value is basically to reject the null hypothesis. Okay, then is going to be your critical value. That means your calculated value should be greater than your critical value to reject the null hypothesis. And third, your confidence interval, both the signs should be the same to reject the null hypothesis. Let's look at the next table. Okay, the next table is again paired t-test. Now you guys will solve this table. Okay, now you guys are going to solve this table. First, tell me what about the p-value? What is the p-value in this? 0.0. So can I reject the null hypothesis based on the p-value? Yes, my data, my study is statistically significant. Second thing, continue assuming that I told you that my critical value is 1.89. If my critical value is 1.89, then still significant, because what is my calculated value? 7.997. So calculated value is greater than the critical value. So your test is statistically significant. And what is my confidence interval? Do both of them have the same sign? Both positive. So can I say that this study, that range of whatever they are doing, that the range of motion with brace, range of motion without brace, whatever they are comparing, it is statistically significant. You know how to read this table now? For critical value, we do not, for calculated value, we do not always use T. Okay, we do not always use T for calculated value. Depends on what is the test that is done. We were using T because it was a T test that was done. For critical value, they will tell you that this is the critical value and they will give that to you. Okay, they will tell you what the critical value is. Okay. Okay, the next one. Okay, now the next one I want you to see, it says correlation. Can you see range? So they're correlating the range of motion with brace and they're correlating range of motion without brace. What is the correlation between this? How much is the correlation? It's 0.147. What do you think? Is this a strong or weak correlation? Very weak correlation. That means range of motion with brace and without brace is not correlated. Now, is this correlation, whatever you've achieved, the weak correlation, is this statistically significant? Now, for that, you will look at the SIG. Can you see the SIG that is written? Sometimes the p-value will also be written as your SIG. SIG means significance. So the significance is 0.685. Is it less than 0.05? No. So this study does not have a good correlation. Neither it is statistically significant. Can you say for that from this? It's not significant and it does not have a good correlation. Instead of 0.685, if you had instead of 0.685, if you had 0.01 as a significance, what would you say? You would say that it is a weak correlation, but the study is statistically significant. Okay, why is it weak correlation? Because Priyanka, your correlation closer it is to 1, that is stronger. This is 0.147. That means this is like between 0.00 to 0.25. That means it's a very weak correlation. Okay, everyone clear with this one? Understood this, how to read this table? The next one talks about film scores and between control group, PRE group, and total group. Okay, now just look at the last table. Okay, look at the last table. What do they tell you? They tell you sig. What does the sig means? Significance, right? It's your p-value. So what is the p-value? Is it less than 0.05? It is less than 0.05. So that means it is statistically significant. Whatever Mann-Whitney test they have done is statistically significant. Okay. Now, do you have one more table which says SPSS? Okay. In that, they've told you that they're checking the cadence scores in a control group, in a progressive resisted group, and in an aerobic group. Okay. Which one do you think is statistically significant out of this? Is it the control group? Is it the PRE group? Or is it the aerobic exercise group? It's going to be the PRE group because it should be less than 0.05. Only one that is less than 0.05 is the group with your progressive resisted exercise. So that's going to be the PRE group is going to be statistically significant. Clear? Okay, these are just tables. I got these tables from my DPT class, like when I had the research DPT class, and I actually clicked these pictures from my own sheet because I have seen like questions like which is given as a random table in the exam and we're supposed to identify things from the table. Now, I don't know how it's going to come in your exam, but at least if you have an idea of the table, you will be able to do it, right? Okay, perfect. Next, let's see what else do we have. Yes, in case they show up, you should know how to read a particular table. So are you guys clear with how to identify what is a hypothesis, what is a null hypothesis, what is type 1 error, what is type 2 error, what is how do we reject the null hypothesis by p-value, by critical value, calculated value, and you also know by confidence interval. So you exactly know how you are making sure that a test is statistically significant. Good. Okay, sensitivity, specificity, something we had already done before. Okay, now what else do I have to teach you? Okay, now let me see, did we miss out anything? Okay, now there is something which is called as a likelihood ratio. Okay, now I don't know how much of the likelihood ratio is going to be asked in your exam. Okay, but it has been asked previously, not very commonly asked. Like every cohort you may have like one question of research which you'll be like, oh my god, I have never heard about this, but the other questions are going to be very familiar and very appropriate if you know research. Just likelihood ratio, I've heard that, okay, that has been asked in the exam, which is why I'm going to teach you what your likelihood ratio is. It's not complicated. Okay, it's not really that complicated, and your calculations in your exam are also not going to be very complicated, so don't worry. Okay, let me first send you what is the likelihood ratio. Is that Beatrice's favorite one? You guys are funny. All right, just sending you some formulas right now, but 1 minute. Let's look at likelihood ratios. Okay, now why do you use likelihood ratios? Tell me, why do we use likelihood ratios? Have you heard why do we use these likelihood ratios? No one knows? Very good. You use likelihood ratios to rule in and rule out a condition. Okay, we use likelihood ratios to rule in and rule out a condition. Now, if you are, let's say, if you're using, now you'll tell me why not sensitivity and specificity. Sensitivity, specificity is also used to rule in, rule out conditions, right? Sensitivity, specificity is also used to rule in and rule out the condition. Then why are we using likelihood ratios? Because likelihood ratios in your research are stronger. They're stronger than your sensitivity, specificity. Why? Because they use sensitivity, specificity itself in their own formula. So look at the formula for positive likelihood ratio. What is the formula for positive likelihood ratio? Can somebody tell me what's the formula for positive likelihood ratio? Sensitivity divided by 1 minus specificity. Good. That's your positive likelihood ratio. What is your negative likelihood ratio? Negative likelihood ratio is your 1 minus sensitivity divided by your specificity. Excellent. So if they give you that you have a sensitivity and your Dolly, that was your sentence. That was your those are your positive and negative predictive values. Those are not your ratios. And that we just told that the likelihood of a person having this condition. Okay, that was just your positive predictive values. That was just your English that you were talking that, okay, likelihood or a probability of a person having testing positive if he has the condition. This is a ratio. Your likelihood ratios are used to rule in and rule out a condition. Likelihood ratios are stronger than sensitivity and specificity. Why? Because they include sensitivity, specificity in their own formula. Right? So now your likelihood ratio, let's say you have a positive likelihood ratio. Now, what should your positive likelihood ratio be for you to be able to rule in the condition? What is the positive likelihood ratio that should be to rule in the condition? Your positive likelihood ratio should be greater than 10. So if whatever like you calculate, let's say you calculated your positive likelihood ratio with the formula that you told me. If you calculated, like if let's say if sensitivity is given to you, specificity is given to you, can you calculate the positive and negative likelihood ratio if sensitivity and specificity is given to you? Okay, so after you calculate it, if your positive likelihood ratio is greater than 10, what can you say? You can say you can rule in the condition. Okay, if it's greater than 10, after calculating the positive likelihood ratio, if it says that it is greater than 10, you can rule in the condition. If your negative likelihood ratio is less than 0.1, then we are going to rule out the condition. So if the negative likelihood ratio is less than 0.1, we rule out the condition. Then what about between 0.1 to 10? What about between 0.1 to 10? If anything lies between, like let's say when you calculate, if it is between 0.1 to 10, it's actually not significant. You cannot really make a conclusion whether you want to rule in or whether you want to rule out a condition. You cannot say that. For you to rule in, the positive likelihood ratio has to be greater than 10. For you to rule out, the negative likelihood ratio has to be less than 0.1. Is that clear? So all you need to know is the formula for likelihood ratio, positive likelihood ratio, formula for negative likelihood ratio. Why do you need to know this? Because let's say you calculate it and your positive likelihood ratio is greater than 10. That means you can rule in the condition. On calculating the negative likelihood ratio, if you see that your negative likelihood ratio is less than 0.1, then you can rule out the condition. If it is between 0.1 to 10, you cannot rule in or you cannot rule out because this is not really significant in ruling in or ruling out a condition. It may be, they may call it like if it is less than 10, they will call it a small positive likelihood ratio. If it is greater than 10, they'll call it a big positive likelihood ratio. Okay, is that clear about what is likelihood ratio? It is used to rule in and rule out a condition. Somebody, there is something which is like, which I want you all to know, which is pre-test, post-test. I will send you that picture. Give me 1 minute before that, because last cohort, somebody had asked me odds ratio, because Score Builders has it in their practice question. What is odds ratio? Odds ratio is, it tells you if an exposure, if you are exposed to a disease, will you get the disease or will you not get the disease? That's your odds ratio. Your odds of getting the disease, your odds of not getting the disease to exposure, that is called as your odds ratio. Let's say you are in contact with a patient who had COVID. Are you going to get the COVID or no? That's like your odds ratio. Now, odds ratio also, you don't need to know how to calculate it. Just know that if your odds ratio is greater than 1, what does that indicate? If your odds ratio is greater than 1, that means if you have been exposed to that particular virus or to COVID, there is an increased risk of you having the condition. That is greater than 1. If your odds ratio is less than 1, that means even though you've been exposed, there is a decreased risk of you to contract the condition. Okay. And if your odds ratio is equal to 1, does not really tell you, it again does not tell you that it will increase. It does not basically tell you the risk of contracting the disease. So it does not really tell you whether you're going to contract or you're not going to contract the disease. So this is your odds ratio. What is your odds ratio? Odds ratio just tells us it's the outcome of whether after an exposure, what is the chances of you to get the disease or no. So if your odds ratio is greater than 1, that means if you've been exposed, you have increased chances of contracting the disease. Your odds ratio less than 1, if you've been exposed, there is decreased chances of you contracting the disease. Okay, makes sense? Awesome. Okay, now the last thing is also related to your likelihood ratio. It's your pre-test, post-test. Okay, I'm going to send you a picture. We're going to do that too. And then it's going to be the last thing in research. Okay, just bear with me for 10 more minutes. We will be done soon. I purposely break down research into 2 classes because it's too much to get it all in one. First thing I wanted to see the first table that is there. Okay, that first table, do you see that table that's called as a normogram? Okay. Okay, do you see that the table which says number 4 here? Okay. Now you see they have this table that is called as a pretest probability, then they have a likelihood ratio, and they have a post-test probability. So this is a table that is given, okay? So everything on this side is your pretest probability, okay? It's your pretest probability. Everything on the right side is your post-test probability, okay? It's your post-test probability, whether you have the condition, you don't have the condition, post-test, and this is your pre-test. In the middle, you have your likelihood ratio. Now, what do we do with this? Let's say they tell you, like in the question, they tell you that your pretest probability is 70. Then all the likelihood ratios are arranged here, and they told you that your likelihood ratio is 20. Your positive likelihood ratio is 20. What does that tell you? Is there increased chance of having the condition or decreased? Positive likelihood ratio is 20. Does it tell you rule in or rule out? Rule in, right? Increased chance. Anyways, in this, they have asked you what is the post-test probability. How do you, if you've been given the pre-test probability, you've been given the likelihood ratio, how do we identify the post-test probability? We just draw an imaginary line. Yes, we just draw an imaginary line from 70 to 20, and we extend it all the way wherever it comes. So something that is, it's not going to, so your option, it could be 96, 97, 98. It's just in the middle. If they give you an option in the exam, the options are not going to be this close. The option will be 70, 80, 90. So you know that this is going to be 95 something, because when you combine, when you draw an imaginary line from 70 to 20, you see that your post-test probability is somewhere between your 95 and 99, right? Now, similar, so it's pretty simple. So you look at the next question. Okay, that next question really tells you how a question can be asked, okay, for likelihood ratio. So if we see, let's read the next question. It says that a teenage girl is suffering from dysuria and is suspected to have urinary tract infection and will undergo a lab test to check the WBC levels. Okay, so teenage girl suffering from dysuria suspected to have urinary tract infection will undergo a lab test to check the WBC levels. The pretest probability of having the urinary tract infection is 30%. A likelihood ratio is 2. What will be the post-test probability? So it is 30 and 2. So what will you draw an imaginary line from? You'll draw an imaginary line from 30 and 2. When and what should the imaginary line be? Somewhere between 40 to 60, right? No matter who, however imaginary you draw, it should be somewhere between that 40 to 60. Now let's look at the options. 5, 73, 30, 46. It's easy to identify 46 because you know that it is going to be closer in that range. When you draw an imaginary line, is 46 easy to identify in this question? So your options will be like that. If they ever give you the chart like this to identify what is the post-test probability, just remember you have to take the pre-test, you have to take the likelihood ratio and draw an imaginary line from the pre-test to the likelihood ratio to find out the post-test probability. Okay, so you now also know if your exam ever has a likelihood ratio question, you know how to calculate a positive likelihood ratio, you know how to calculate a negative, you know what is ruling in a condition, ruling out a condition. You also know how to use the likelihood ratio to find out the post-test probability, and that's how much you should know. And you also know your odds ratio. Okay, one more thing which you should know, okay, which I didn't, I know I said this is the last thing, but it's just a definition. Okay, one more thing that you should know, which is just a definition, is your MCID and MDC. Have you heard about the terms MCID and MDC? MCID is minimal clinically important difference. Okay, this is very important. You should know what is an MCID. Okay, MCID is a minimal clinical important difference. Okay, let's say you work in an outpatient clinic. You see a patient, you are giving the patient ultrasound. You're giving the patient ultrasound for, let's say you're giving it a thermal ultrasound to improve the range of motion. Just assume, okay? Day 1, day 2, day 3, day 4, you start seeing a slight, you actually clinically see the difference that is happening. It's not the same. When you measure, you see that the patient is making progress. So if there is a whatever difference is happening clinically is called as a minimal clinical important difference. So whatever difference that you see after giving that particular test to a patient, clinically, the difference that you see is called as a minimal clinical important difference. Then what is MDC? MDC is a minimal detectable change. What is a minimal detectable change? This is not clinical. Okay, MCID is clinical. So whatever I see in the clinic, whatever changes are happening, whatever I see in the clinic, that is a minimal clinical important difference. But MDC is a minimal detectable change. That means the difference, my statistical study. Okay, so when my whatever, like let's say I say that my study is statistically significant, by how much is the difference? Like, let's say if I say that, okay, TENS is better than ultrasound, then I am not clinically seeing it. By how much detectable change statistically is the difference? That is my minimal detectable change. So MDC is not something you use clinically. It is all related to your statistics. The minimal statistical difference that you have is called as a minimal detectable change. Okay, that's after doing a study. But MCID is what you see in the clinic. So when you work on a patient and the difference that you see clinically is going to be your MCID. Okay, so know this, what is MCID and what is MDC. This much is enough. You just need to know what it is. So if they tell you that, okay, if the patient, if a therapist is seeing a difference in the range of motion in the clinic, what is it? Is it MCID or is it MDC? It is your MCID because it's a minimal clinical important difference. Okay, is MCID better than MDC to start a new intervention? Not really. MCID is something that you see clinically. So like in your clinic, you will be using a lot of MCID rather than MDC. MDC is going when you're reading articles and you're seeing which is the most effective thing and all. That's when you use, like for evidence, like you're actually reading evidence-based practice, you're checking the difference, that's your MDC. But MCID is what you're actually seeing in the clinic. Okay. Is that good? Everyone understands what is MCID, what is MDC? Perfect. And also, I think somebody had asked me, what is an effect size? What is an effect size? What is an effect size in a study? Let's say your study is statistically significant. How much, the size of the effect, like how much is, if like it's basically the magnitude. Yes, how much is the effect? That is called as your effect size. Okay. Yes, a big sample size will have a good effect size. Yes, because a big sample size always helps in reducing the errors. So that means your effect size could be better. Okay. Everyone good so far? This was everything important that I could think of to teach y'all in research. I think both our lectures have covered all the key topics from research that we know. Okay. Now I think someone shared on the group the research questions. Now you can go and you can review those research questions, try to get all of them correct. All right. And if you don't get them correct, you can put them on the WhatsApp group and I'll help you out. Okay, I'm going to stop the recording here.